Welcome again.
Welcome to the developer workshop. Can we... good. So we have quite a long time together this afternoon, about 2.5 hours. I'll show the agenda in a moment, but we will take 2 breaks through the course of the afternoon. My name, of course, is Michael Herman, and I'm very pleased and very proud to be here today. So I'm an independent blockchain developer. I work for myself. I've been working on the Ethereum blockchain, and I now work on the Neo blockchain. I have many years of experience with software development. I've worked for Microsoft, I've worked for IBM, I've had my own small company. I've worked for companies of all different sizes, so hopefully I can be understanding and sensitive to your needs. For Neo, I am the curator, the person who looks after the Neo C# Developer Center of Excellence. That's on GitHub, and we will be going there and we'll have a look at that content. This PowerPoint is also on GitHub, and we're gonna I'll show you where you can go and download that as well. How many people brought their laptops? They brought their computers today? Quite a few. Okay. So the intention is to actually get you started being able to use Microsoft Visual Studio to develop smart contracts for the Neo blockchain. I've tried to find the simplest path for us to follow, and there's a little bit of setup, a little bit of preparation we'll have to do, and so we'll get into those steps in just a moment. So I want to understand a little bit more about who is sitting in the audience. How many people are software developers? Okay. How many people have used Neo for smart contract development, created Neo smart contracts? Just a few people, okay. I didn't talk to these people before, but the people who know Neo a little bit, can you stand up? Can I ask you to stand up if you know Neo? Because one of the objectives for today is not only for me to tell you a little bit about Neo, the Neo platform from a software development perspective, but I also want you to connect with each other, the people who know about developing on the Microsoft platform, the people that know how to develop with Neo. I know one of the fellows over here, Farouk, is starting a Neo blockchain meetup group in Istanbul, and I know that he's quite knowledgeable. I've also met a few other people through the course of today. So make sure that you get to know the people beside you and the people in the front and the people in the back. If you have questions, we'll try to I'll answer all of your questions. If you're having any problems with some of the software, it might be a little bit difficult in this room, but I will stay here and make sure that everybody gets connected. Anybody using Ethereum for smart contract development? Okay, a few more. How many people primarily use the Microsoft platform, like Visual Studio, for software development? Okay, good. How many people aren't software developers? Okay. My understanding is that there's a lot of people here from both the Turkish government and the Turkish banking industry. How many are from the government? Okay. And how many people are in the banking or financial services? Okay, good. So we have quite a diverse group, how many people are students? I know there's lots of students. Okay, good. Okay. So this morning, Malcolm, in the keynote presentation, talked about the Neo smart economy being these composed of these three main assets: digital assets, smart contracts, and digital identity. So today, what we're going to do is we're going to be zooming in on smart contracts, and one of Malcolm's quotes, I don't remember him using it this morning, but I saw it on one of his videos. He talks about a future world where the boundary between real assets in the physical world and digital assets in the digital world have been removed. So the idea is to incorporate these three aspects into this new world, this new smart economy, where we're able to blend, let's say mostly from a business perspective, but also from a personal perspective, what's happening in the physical world with what's happening in the digital world. And so we're going to kind of use that as a bit of a theme, a bit of an idea for how we walk through the rest of this afternoon. The real focus is around enterprise application development, and I'm being very specific about that because one of the things I don't do, maybe I'm very non-traditional, is I don't get too involved in coins and tokens and cryptocurrency. I'm interested in using smart contracts and what I call smart data, living on the blockchain for building business applications. So if we think of, and I know that some of the print here is quite small, but if we think of how you build applications on Microsoft, you have the front end, you have the middle tier, and then you'll have some sort of database, SQL Server or Oracle or DB2 or whatever, traditional multi-tier enterprise application, but you might also be building using a full stack, using Node.js and HTML, CSS, JavaScript, or maybe you're a Python developer. I met some Python developers here who are also doing some Neo development. And so you may be using Python in the front end and the back end, and one of the nice messages around the Neo platform is that when it comes to creating smart contracts, you can use whatever language you want. So for example, if you're a Microsoft developer and you like using C#, you can use C# to create your smart contract. You could use Java, for example, for smart contract development, or you can use Python. You could use Python with the Microsoft stack. You could use C# with the Python stack. So whatever tools, whatever programming languages you like to use, you can use that to create your smart contract. And what I've shown here is that smart contract programming or creating business applications using smart contracts isn't something brand new. It's just something more interesting, something special that you can add to your existing applications. And we're going to talk in the next couple of slides about what is the criteria, what is the reason that you'd want to use a smart contract with a traditional business application. I know this is a big group, so I can't ask too many questions, but is that pretty clear for people so far? So when do we want to use this blockchain technology? When do we want to use a smart contract? So I have 4 questions, and I actually borrowed these from a very good Microsoft document called Blockchain, the Force Multiplier for the Smart Economy. I don't know if Microsoft took that from Neo or Neo took that from Microsoft. I think this came after, so maybe it's Neo's idea. But questions to ask: is it a business process that covers trust boundaries? We heard that as a theme throughout the day. If you're just building a business application that's going to run inside your company, maybe there aren't big trust issues. Maybe the blockchain, maybe smart contracts aren't the right technology. But if you're creating a business process that runs across trust boundaries, we heard about supply chain scenarios, supply chain use cases. We've talked or heard about complex banking and financial transactions, where the parties, the people involved, the companies involved don't know each other. How can they work together? How can they collaborate? How can they take a shipment of corn, let's say from Canada, and make sure that it gets to China, and all the different financial documents, the letters of credit, how do all of those get negotiated between the banks, between the farmer growing the corn, between the customer in China who's buying the corn? So whenever you have a business process that crosses trust boundaries, that's potentially a good application for blockchain. When multiple parties, multiple companies, multiple organizations have to work with the same data. You know, we used to call that sort of extranet scenarios, where you have data that needs to be in the middle shared by multiple companies. So that's another scenario. And they tend to work together, that when you have multiple parties, multiple organizations working together, they may know each other a little bit, they may know each other a lot, but trust gets multiplied the more people, the more organizations that are involved. Do you have processes that are operating inefficiently, or decisions that are being delayed because there's so many people involved in the process? There's many intermediaries. We also heard that as a theme in the talks today. Does the business process involve low-value manual tasks, manual verification steps? That's often the role of intermediaries. During dinner yesterday, we were hearing about the role of the notary public here in Turkey. They're often involved to authenticate documents. When Malcolm talked about his official Swedish papers having to be verified by a notary in Sweden, that's often an example of it's important to the agencies, important to the government agencies that are involved, but it's really a low-value manual verification step. So when you have applications, when you have opportunities that experience, you know, let's say 2 or 3 or 4 of these types of questions, then that's the time to start thinking about using the blockchain. The blockchain isn't an answer for everything. So when you have that question of, does the business process cross multiple trust boundaries, the blockchain can enable real-time transparency, real-time visibility into what's happening. Sometimes what we call a single source of the truth, that all the parties, all the different applications, the business applications, can operate on and share. Real-time, transparent access to a verifiable single source of the truth across organizational boundaries. So the key different thing here is the fact that it's a verifiable source of the truth. I'm not going to go into, explaining how the blockchain works. I think a lot of people are very familiar with that already that are in this room. But the fact that the trust is based on what's called trustlessness. So you don't have to trust the parties involved to have a sense of trust. I hope that translates well. Because the blockchain is out there, and the way that it's constructed allows you to verify what the truth is at any given point in time. So when you have processes that involve all these intermediaries, there's the opportunity to automate a lot of those processes, increase the efficiency, and also it has the effect of reducing the trust. The fewer people, the fewer organizations that are actually involved. And lastly, the idea of these low-value manual interactions, decisions, verification steps that have to be made. The whole idea of the smart contract is you're taking software and you're wrapping it around data. So what you're doing is you're making that data smart. You're giving the data the smarts to be able to do some of these steps that we're talking about. So if we think of the previous slide where I talked about the architecture of a multi-tier business application, and we now have the ability to use smart contracts to create smart data on the blockchain, this helps us guide us to when we actually want to do that. Gartner Research had a webcast last week, and the fellow there talked over and over again about use blockchain when it matches the requirements of your application. Do not automatically use blockchain just because he used the term re-platforming your application. If you're just taking an application that doesn't have these qualities or these characteristics, and you're maybe updating it from an old technology to a new technology, that's not necessarily a good reason to use blockchain. Use blockchain when your application has these characteristics, or you want to add these trust capabilities to an existing application. But if you're just re-platforming, if you're just going from Unix to Windows, or from Windows up into the cloud, a simple re-platforming, then it doesn't necessarily make sense. So I'm kind of getting towards the end of the introduction here, but what I want to highlight is today a lot of the involvement of the blockchain has been around cryptocurrency. And so this is kind of my favorite diagram. If you're familiar with how you make a token either on Ethereum or on Neo, it involves on Neo NEP5 is the specification, and on Ethereum it's ERC20. And there's a function, an operation called transfer. And that's used to transfer assets, cryptocurrency, from one person to another. And if you think of what's happening in the crypto market, it tends to be either this spiraling up and the price goes up, or it's spiraling down. But it's really just about exchanging cryptocurrency assets and sometimes fiat. But there's no real business process there. There's no real value coming through. So I've been thinking recently, this is a personal project that I'm working on. I'm kind of using it to guide what we're doing today. If we think of transfer as being the main operation when you're creating a token, what if you took a business process and instead of just thinking about transferring cryptocurrency, let's say you had a requisition. And by a requisition, I mean like a expense account, an expense claim, or you're submitting a timesheet, and what you want to do is you want to get paid for your expense claim, or you want to get paid for your timesheet. Or maybe you're a humanitarian organization and you're doing disbursements to people, disbursements of funds. So the idea is that there's a requisition and it flows through a process. You can't read this, but if it's a small disbursement or a low value of your expense report, let's say it's less than 400 lira or 500 lira, maybe you have a business rule that says that gets paid automatically. Or maybe it's a little bit more money and it needs to go to an accounting clerk or somebody else just to look at it quickly before you get paid. Or maybe it's a larger amount and it maybe needs to go to an approver, to your manager or to a senior manager before it comes back to the payment clerk to get paid here. So what we have is a flow here, not just of cryptocurrency, but we're actually envisioning taking a requisition, like an Excel spreadsheet or a PDF or an XML document, and that becomes part of the transaction. We transfer the requisition into the smart contract. The smart contract is able to help make these decisions about what kind of review processes we need, what kind of verification processes we need. The smart contract could route it to the different people depending on the business rules that you need, and eventually a payment happens. So it's only this last step where you might use a traditional transfer operation. So this is where, when we think of the smart economy, the melding together, the blending together, the physical world and the digital world, this is a fairly simple example. but I just want it to I want you to use it to think of how can I apply this in a more constructive way than just, you know, trading currencies on an exchange. So when it comes to implementing this, you can actually take a lot of the same ideas that we use for creating NEP5 or ERC20 tokens, and we can think of the smart contract actually routing the requisitions and routing the payments between addresses, just like we have over there, or you may have more sophisticated services for doing that. But in the end, it's the smart contract operating on data. And that combination together, I call that smart data. Data that is wrapped in software, data that can implement the business rules for you. So here's just a few examples that if someone were to create a general specification for processing requisitions, where a requisition is a document with a few instructions associated with it. I mentioned expense reports, timesheets, contribution reports, lottery tickets. Anytime you have a claim to get a payment, it could be a lottery ticket. Earlier today we heard about loyalty programs and loyalty points, discount coupons, vouchers, stock certificates, you know, disbursements. Anything that is a simple claim or a simple request to be paid that may require different levels of review or approval, but in the end, it's kind of like traditional cryptocurrency that once that decision's been made, it's just a question of sending the person those funds. Okay, so what is the real purpose and the goal for today? With that as kind of a framework to talk about. So I want to provide you with hands-on smart contract development experience. So we're going to use, you know, Visual Studio, the C# programming language. If you don't have to be very familiar with those. All the code I've created, you'll be able to go onto GitHub, you'll be able to download it and use it. So that's the real goal for today. Other assumptions that, you know, the audience is mostly architects and developers, that you're familiar with the blockchain already, that I don't have to explain the first principles. I'm not assuming you have any experience with Neo, but you might have a little bit of experience with Visual Studio. And in the end, I want to provide you with a level of awareness of understanding, some hands-on experience building those small contracts. And as I mentioned in the last bullet here, you know, the beginnings of creating a strong Neo community here in Turkey. That, again, I encourage you to meet with your neighbors, to meet the people behind you and in front of you. I'm also going to show you the Discord tool, the Discord website that Malcolm mentioned this morning, and that's another place for the Turkish blockchain community to meet with everybody else that works on Neo. I work on Neo, when I'm not up on stage, I work with the Neo blockchain software 14 hours a day. An example of the people who I'll interact with, once in a while I'll interact with Malcolm, but I often work with the other developers in the Neo community. So there's Sergio, he lives in Portugal. He's the lead developer on the debugger. Chris is responsible for another tool called Neo GUI. He lives in Australia. There's another fellow who looks after the Neo compiler. He lives in China. And so it's a very connected group, and we all connect through the Discord tool. So the agenda. The good thing is we're finished the first part. We only have 11 more sections to go. So we're going to spend some time preparing our laptops. I know there were some instructions that were sent out a few days ago, but we'll go through a process of preparing our laptops, and then we're going to do three quick three quick hands-on labs, starting with the Hello World lab, so that make sure that you've got the right software on your laptop and that you're able to do the basic things. And then I'll talk a little bit more about why Neo, why I think it's special. And then we'll have a break. Then I'll talk a little bit about the architecture. I'm a developer and I'm an architect, an enterprise architect, and I find, at least for me and for others, that you can tell somebody kind of how things are supposed to work, but if you kind of give them the picture, if you show them, for example, how the development tools connect together, how they work with the Neo virtual machine, how the Neo virtual machine is part of the Neo blockchain, that helps a lot. So I'm going to go through some pictures and diagrams there. Then we'll do 3 more labs. Because part of programming smart contracts, whether it's on Ethereum or whether it's on Neo, is there's certain patterns. You tend to build your software in a certain way, and that's very much the case with Neo. So we're going to do some simple pattern, or look at a simple pattern, and then we're going to look at, I call it a domain name service. So if you're familiar with DNS on the internet, this is an example of how you might implement DNS if you were going to implement it in a smart contract. It's a simple example, simple to understand, but it follows the same pattern that you'd use to create an altcoin. And the last lab, the last of the 3 labs in Module 2 will be creating an NEP5, a sample NEP5 token. And then we'll go into a little bit more of why Neo, and then we'll have a break, and then we're kind of into the easiest part here. There's just more information I want to leave you with so that you're able to be more self-sufficient, so you know where to go to learn more about the Neo platform. Okay, so one of the things that I need to communicate to the people that have laptops is where to download different things from. So what I've done is, talking with the people here at the workshop, they've created a hashtag, hashtag blockchain Turkey on Twitter. And so I'm going to send links on Twitter to that hashtag. So if you can go and find that hashtag on your laptops, then that'll be a way that I can communicate easily and quickly with everybody here in the room. So if I go, I'll be going back and forth through many different programs here. So, and I'm pretty informal. Oops. There we go. So for example, the first tweet that I want you to find is this one here. Oh. Or I could just drag it over. We can go back to extend. Oh, that's fine. That's fine. I can get it now. Yeah. Thank you. So if people can find this tweet, just go to Twitter and look for Blockchain Turkey. And there's a link there, which is the Discord link. And I want you to click on that link, and that'll allow you to join the worldwide NEO community. So you click on that. And it'll bring you to here, and then you can just continue. If you want to, it's your choice. But if you want to, they have an app as well. Let me show you the app. Try to get it over there. There we go. So this is the Discord app, and this is the NEO community. And if I click, for example, on people, you can see all the people that I work with. There's Malcolm, and that's Sergio. And inside here, you will find different channels. So if you're a C# developer, you can click on the C# channel. And this discussion runs 24 hours a day because we have people all over the world working on NEO. So this is the best way to get connected. Also, don't be shy. Post any questions, and people are there to help. People like myself, there's dozens and dozens of experts that are watching the questions. You'll probably get more than one answer, more than one solution. And so that's the Discord channel. I'll also show you now how to get the content for this workshop. And I will so this is the name of the workshop, and it's up on GitHub. And what I will do is copy this, and we will send it. I'll send it to you on Twitter. And so if we go back onto that page, what you'll find is there's all the steps involving the preparation that we're going to go through, and I will show you that on the slides. There's a few steps. This is the presentation. This is the PDF version of the PowerPoint that you can download. And then underneath the presentation, there's all the labs. There's the 3 labs in Module 1 and the 3 labs in Module 2. And we will work through as many of those as we can. We might not get through all of them, but all the information is here. In addition, at the bottom, there's other resources and other links to help you. If you've been able to go to Twitter and find that page, put your hand up just so that I know there's a okay, good, good. Okay, so I'm not going to check your homework at the end, but I've given you 2 pieces of homework now. One is to join the Discord group. Malcolm said make sure they get in the Discord group. And then the second thing, you have all the information that we're going to be talking about, but you can't leave until the end, just because I've given you the information first. Okay. So let's go through some of the steps that we need to focus on. Cool. So number 1, done. Number 2, done. Number 3, I guess this is just my personal preference, using Visual Studio, so we'll use that today. And there's the Community Edition, which is a free version of Visual Studio. It's remarkably complete. It has almost all of the features that I ever use in Visual Studio, and it is a really good environment for creating C# contracts. So you create a C# smart contract just the same way you'd create like what's called a console application, and I'll be showing you how to do that. We're also going to download the debugger. So we're at a stage, this is an open source project, we're at a stage where you still download. To download the tools, you download the source code for those tools. I don't know if it was mentioned earlier, but all of the Neo blockchain, all the software infrastructure is all written in C# using Visual Studio. So the same tools that we're going to use this afternoon to create our smart contracts is the same tools that all the developers around the world use to create all the tools, to create the consensus nodes that we were talking about earlier. So this is a good thing to have. You're also going to need something called the 4.7.1 developer pack. All of these links are on that GitHub page. So hopefully people got the email over the weekend and perhaps have had a chance to install Visual Studio. How many people have Visual Studio on their laptops already? Okay. Okay, so this is good. This is probably the only thing that you might not have. This is fairly recent, and the Neo debugger requires this developer pack. But again, if you're on the GitHub page, you can see that 4.7.1 developer pack is there. Okay, so the next thing we need to do, so if you forget, you're going to get this message here, and what you want to do is just cancel it and then go download the 4.7.1 dev pack and start the process again. So the Neo debugger, so there's many tools that are part of the Neo developer suite, but I tried to find the simplest way for you to begin developing smart contracts, and Sergio has created some new additions, some enhancements to the debugger. So we just need two tools. We just need Visual Studio and we need the debugger. And that will allow us to create smart contracts, and I'll explain why that is so easy to do that. We don't need private net, we don't need test net, we don't need mainnet, because what the debugger does is actually runs a copy of the Neo virtual machine, which is all we need to develop and test. Initially, that's all we need to develop and test our smart contracts. Once you get it working in Neo debugger, then you can worry about private net and test net and mainnet and getting gas and stuff for those. But you can do probably 85–90% of your development and your testing just using the debugger, and that's what we'll use today. And when we get to the architectural discussion, I'll explain a little bit more what's there. So again, this link is on the GitHub page. So I've created, or through GitHub, I've got this zip file, this archive that has all the source code for the debugger. And if you could download it and copy it into a folder like C:\repo, just so we have it all kind of in a similar place. You can put it wherever you want afterwards, and then go through and unzip that so that there's a folder called Neo Debugger Tools in that. It's very hard for me to gauge how quickly you're moving through these steps, so I'll try to pace myself a little bit, slow down a little bit here at the beginning, so that people can keep up. If it's easier just to watch what's going on here, again, you have all of these steps and you can be able to do that, you know, tonight after you get home, and we'll have the test in the morning then instead of at the end of the day. That's just a joke. If you got the email over the weekend that asked you to download this master.zip, it was updated last night. I found a little thing and Sergio fixed it quickly last night, so make sure you download a fresh copy today. This is, I intend the PowerPoints, the presentation, the PDF file to be kind of a complete record of what we're doing. So I've got lots of screenshots, and this is just an example of what the debugger looks like. So you do all of your development in Visual Studio, and you create the smart contract. We call it the AVM file, and then the debugger reads that and will show you all the source code, the C# lines. It also works if you're creating your smart contracts with Python or Java or any of the other languages. You use the same debugger. You press F10 to single step. The first time it'll bring up this window, and you can put your commands like transfer. I want to transfer from this account to this account, and I want to transfer, let's say, 100 tokens. And so just 3 simple steps. F10 to single step through line by line. You can look at all the values as you single step, and then if you just want to run it to the end, you can press F5. And then to look at the storage, so you have the ability in your smart contract to save values into the Neo blockchain, into Neo storage. And by pressing F6, that'll bring up a window that will show you the contents of what's in Neo storage. So this is a very, very powerful tool. When we use it today, we're going to use Visual Studio. We're going to create our smart contract AVM file, and then I'm just going to have you manually start the debugger, but we can hook them together so that that process can become very, very fast, just like you're familiar with debugging in Visual Studio already. Okay, so how many people have downloaded the debugger and unzipped it? Very good, good, good, good. Let me just see what the next slide is here. Yeah, so this is the steps we have to go through once we have the debugger unzipped, and so all the source code is on our computer. And I've kind of labeled the steps here. So A, that's just showing you that we've got the debugger files, the debugger source code, and what we want to do is double click on the neo-dev-tools.sln file. Before you do this, you need to make sure that you've installed that dev pack that I talked about, the 4.7.1. When it opens in Visual Studio, we go to step C, we right-click on the solution, we say rebuild it, and then we'll see all the different projects being rebuilt. There's the Neo debugger isn't just the debugger, it's a number of different tools. There's the compilers in there, etc. And so you'll see that there's a total of 9 projects that will be rebuilt. This is probably this is like the most technical part, just getting that built. And then what we'll do is we'll just run the debugger out of Visual Studio to make it easy. So at this point, you have Visual Studio, you've downloaded the source code for the debugger, you've compiled the debugger so it's ready to be used. There's one more step that we have to go back to the GitHub page for. So there's the screen I was just showing you. You need to put the debugger into your Windows path, to your search path, so that when you type in like the name of the compiler, that Windows will be able to find it. So there's a line here that you can use from that GitHub page. The command is called setx, set extended, I believe. And what you're going to do is you're going to set the path to be the current path plus wherever you've installed and compiled the debugger. To some of you who maybe aren't developers, this is going to seem strange, it's going to seem tedious, but it's for those that are have been developing on Windows, it won't seem so strange. So a few notes here. I try to make it foolproof. Make sure you use the setx command and not set. Don't put an equal sign in the middle here. I did that the other day and it wouldn't work. So these notes are there because I've made all the same mistakes you might make, and I tried to write them down. If you've unzipped it into a different folder, like something different from what I have on the web page, then just make the normal adjustments. And once we have that path set, once we have the debugger compiled, then we're ready to go into the labs. A nice sized group for doing this kind of workshop is about 10 people. And we've got about 15 times that, so it's a little more tricky. I just hope people have been able to follow along, and at the end we have some people who have created smart contracts. So let's look at the first smart contract. As I showed you on the GitHub page, all the source code is there. You can just copy and paste. I also have, I don't know if it's a good reputation or a bad reputation in the Neo community. I tend to show a lot of source code in PowerPoint, and people just shake their heads, I think. So in Visual Studio now, to create your first smart contract, this will seem very simple for people who have done it before, but I also, if you have not used Visual Studio before, I wanted these instructions to be simple and straightforward, so that most anybody would be able to do this. So you go to File, New, and it's going to bring a list of all the different kinds of things, different kinds of software that you can create with Visual Studio. And one of the things will be Neo Contract. And it just occurred to me that I have left out a step. For those that are more experienced with Visual Studio, you need to get a Visual Studio extension. So if you go onto Tools, Extensions, you need to search for Neo and get the Neo Contract Visual Studio extension so that you have this item here. I will update the PowerPoint. I'm missing one slide. I will update the PowerPoint after today, and I'll put it back up onto the GitHub site for you. So you can give the project a name, anything you want. Call it Lab 1, for example. And the default, as soon as you say, I want to create a Neo smart contract, it's going to give you this little example here. This is a more complex Hello World example than I want to show you, but this is the way that you start. And this is using some of the storage operations. We're going to talk more about storage when we get to our third lab. But what you might want to do right here is just say rebuild, because you see all these red lines, the red squiggly lines. That means that there's some software that's out of date, but as soon as you rebuild, Visual Studio will download the software you need. And this example will be done. But what we want to do is take that, and we actually want to replace that code. So there, do the rebuild, and then we see all the red lines go away. And what we want to do is change that one line. And what we're going to do is change it to this line here, which is runtime.log, and we're going to say hello world. So this is more familiar to you as a traditional hello world application. When you look at a smart contract, it may remind you of a type of Windows program that you've seen before. If you think of a console application that's just going to run, or a command line application that you can create in Visual Studio, it turns out that the subcontracts, or the smart contracts we create, are very similar. They have a main, it's public static, it lives in a class. Your main can take arguments. We'll see more complicated, more elaborate examples where we have arguments. This one is not returning any values. You could be returning Booleans. You can return classes. We can return entities. You can return arrays. But this is just the simplest example. But the message here, the key message is, when you're creating a smart contract, a C# smart contract on the NEO blockchain, it's very similar to just creating a console application. You are actually creating a program, a C# program, that runs down on the blockchain. And then when you have your enterprise application, the multiple tiers, your middle tier simply needs to call into the NEO software and say, hey, I want to execute the main method, and then you would pass whatever arguments you would, just almost as if you had typed the name of the program in the Windows command line interpreter. But you do that through software from your enterprise application. You can call into the main. So that's the first example. It's very simple. We just create a NEO smart contract using the template in Visual Studio, and I want you to change that line. What runtime.log does is it sends a message to the NEO event log, and we can see the NEO event log when we run this in the debugger. So I'm going to switch over to my Visual Studio. Actually, what I'm going to oh, there we are. As soon as this opens, I'll bring it onto the screen. Okay. Wrong one. I got to get used to looking at that screen down there. Okay.
Michael, we have two announcements I want to evaluate this time.
Okay.
First announcement is Wi-Fi password. Right now, Ferdi is preparing the password and will be shown in the screen so that people, I think people are still having trouble to install some packages from internet.
What's the password?
Yes, they will show you. They will show to the audiences.
Okay.
The second thing that we promise for the certificates, but we were not expecting that much crowd. Remember that 20 people or at most 100 people. Right now, I think we have more than 200 people. We discussed and we have solved a solution. We end up with a solution. The solution is in a couple of minutes or after your session, we will share a QR code. Let me repeat in Turkish. Arkadaşlar, bu kadar çok kalabalık geleceğini düşünmüyorduk. Bir QR kod birazdan yayınlayacağız. O QR kodu göstereceksiniz, okutacaksınız. İsim, soyisim ve firma ismi dolduracağız. Ondan sonra yarın sertifikanız hazırlanmış bir şekilde teslim edilecek bu session için. Ayrıca katılım belgesi var. Bu programa katılanlar için katılım belgesi var. Onlar da aynı kimlikler gibi soyadı sırasına göre aşağıda yine yarın dağıtılacak. Bir de çanta hediyemiz olacak yarın yetişebilirse. Onlarla beraber hepsini alırsınız. Yani Hemen burada salonda 20-25 kişi olaydı, biz bunu hemen hızlıca yapıp size teslim edecektik. Ama ciddi bir talep var. Dışarıdan da birkaç misafir ben davet etmiştim. Dolayısıyla onlarla beraber epey kalabalık olduk. Bugün bu işi çözemeyeceğiz gibi görünüyor. O yüzden isimlerinizi toplamamız gerekiyor. Bunun da en güzel yolu, bir küçük form yaptık. 3 tane kutucuktan olan Google Forms'dan. Onu birazdan QR kodu paylaşacağız. Hem ekran birkaç sefer paylaşırız, merak etmeyin. Kapıları da asacağız çeşitli yerlere. Cep telefonunuzdan bunu taratıp yapabilirsiniz. Form buradan çıkacak. Görüyor musunuz bilmiyorum. Çalışıyor mu? Biz denedik ama. İsim, soyisim, firma ismi alıyoruz. Firma ismini boş bırakabilirsiniz. Yani bir boş bırakabilirsiniz dersen bireysel gelenler var, öğrenciler arkadaşlar var üniversitelerden. Onlar da üniversitelerin yazsınlar. Sertifikanın üzerinde firma ismi yazmayacak, isim soyisim yazacak. Bunları yarına hazırlamaya çalışıyoruz. O yüzden böyle bir çözüm bulduk. Wi-Fi password'unu bir daha gösterelim. Sorry Michael. Marriott konferansa bağlayacaksınız. UBT 123. Bir de Marriott Public var. Orada da 3 saat ücretsiz veriyor. Okay. Bunu sonunda da gösterebiliriz. Şimdi Michael'ın sesini bozmayalım. Evet. Thank you. Sorry for interruption.
No, that was all good stuff. That was good. That's part of the community, part of working together. Yeah. So if we need that later, I put it into a notepad and we can bring that up. So what we want to do now is once we open Visual Studio and you can go get that source code or you can just change that one line yourself. Here I have a project, a solution that has all the steps for all the labs in it. That's the same project that you're using on GitHub. So you can just right-click on Lab 1 and click Rebuild, and you'll see that you'll get, you want to look for a couple things. You want to make sure that you're getting the Neo compiler with the debugger support, and then this is just showing some of the steps involved in creating your smart contract file, your what we call the AVM file, the bytecode file, which represents the code that's in C#. And I'll explain a little bit more of the details of that process. So you're going to have one copy of Visual Studio open for writing your smart contracts and for compiling them. And then just for today, I'm suggesting that you have the second copy of Visual Studio open. And this is the one where you have compiled and you have rebuilt the debugger. So these are the files for the debugger. And what you want to be able to do is scroll down. And one of the projects is called Neo Debugger WinForms. It's like the screenshot that I showed you before. And so you can just click Start to start the debugger. And this may seem kind of backwards or, you know, why are we building it from scratch? This is just the stage that we're at as an open source project where all the source code is there. And as we evolve, you'll be able to download, you know, already compiled versions, but this is just where we are today. So when you start the debugger, you'll have, for the first time, you'll have to go up here into File Open, and you're going to have to find your project. So so there I'm in Lab 1, and I want to go into the bin, into the debug. And I want to open that ABM file. So that's my smart contract. That's my Hello World smart contract. And there I can see my smart contract in the debugger. And remember, the debugger besides what we see here in the back behind what we see on the screen, we're actually running a copy of the Neo VM. And it runs just as if it was running on the blockchain in a simulated environment, an emulation. So we can go now F10, and the screen comes up. So remember our main program, our main method, didn't take any arguments. So normally we don't have to do anything here. But as we get into the more advanced labs where we have to provide parameters to the main method, this is where we'll get a chance to do that. So we're just going to click on debug to keep going. And I can press F10, F10. Oh, see my little hello world came up here. This is the event log. So we can see hello world. So we 100% successful. You can leave the room now. You're a smart contract developer. So we just go F10. And then at the end, we get the execution finished. And I think Malcolm talked a little bit about the concept of gas. So gas is a special Neo token. And as your smart contract executes, every instruction has a certain cost associated with it. The costs are very small, and we get a total of 10 gas for free. So when we spoke earlier this morning and we said transactions on the Neo blockchain are free, that's true because it's very hard to use that 10 gas. So for example, this simple one here used 0.006 gas. That's like 6 instructions. So we'll talk a little bit more about what we call system fees in a moment. And because we didn't return anything, because it's a void, the result is null. So there's 12 opcodes, 12 low-level instructions that were executed, and it took 0.006 gas to execute that. That's the end of lab number 1. Maybe I can start. Anybody have any questions? Let me just take a few questions now. I don't know. Do we have microphones, or how are we doing questions? Oh, yeah, fella. Does anybody have a question? Yeah? In the middle here. Developing a non-Microsoft environment. So for example, if you're a Java developer, you can use Eclipse in much the same way that I'm doing here. We have a very, Malcolm, what's the right way to describe it? A very energetic Python group. So they tend to use the standard Python tools. They also tend to be more command line oriented. They like to build and test and execute using Python commands. So I would say today there's the C# community and the Python community. We're about kind of equal. Is there a little bit of rivalry? Not usually. So this is for C#, Python, any standard Python development environment, editors, and then, like I said, most of the Python developers like using the command line. And then for Java would probably be the next most common platform. You can use the Eclipse IDE for that. What's your favorite?
Well, Python is fine, just Macintosh.
Yeah, okay. There is Visual Studio for the Macintosh, but I've heard it isn't so good.
Yes, but you had the .NET framework as a requirement, so there is Visual Studio for Microsoft, but .NET framework breaks it.
Yeah, not to get too overly technical, but the developers, for example, who work on the Neo debugger and the other tools, they're very cognizant of using the portable versions of .NET whenever they can. So many of the tools will run in both places, but it's not always the case.
Thank you.
Other questions? One more question? Pardon?
Are we going to see what's behind the smart contract, that implementation?
You want to see the opcodes?
Yeah, the functionality behind it. What we gonna call from the?
Oh, so this is the most simple.
Yeah.
Then we're going to go into one that's a little more, and then we're going to start talking about storage. So we'll go through the different kinds of functionality. Okay?
Okay, thank you.
This is more to make sure everybody has all of their tools working, that Visual Studio is working, that the debugger is working. And everybody wants to know how to do at least the Hello World demonstration. Okay. So if you go back to Visual Studio, you can start that process again to create a new project. We're going to do the next lab. So you're going to go right-click and say Add a new project, and you're going to create or select the Neo contract. Now that I have this open, I can show you under Tools. That's where the extensions are, and this is where you would go to get the Neo contract. So you can go in here and just type in Neo, and there you see the Neo contract plugin. That will download automatically, and you have to actually close Visual Studio, let the installation happen, and then open Visual Studio again. But that will give you the Neo contract, and I'll make sure that I add that. If we go to the second lab, this is kind of a little bit more like Hello World, but it has some very important differences. So we start off using log and notify. Log is for writing messages, just messages to the event log. Notify is used not only to put a message, but to display the value of different variables, different entities. So for example, there's a variable called 10. We're setting it the value of 10, and then we're using notify to print out the word 10 and then the value of 10. That's pretty simple. Here I'm creating an array of different kinds of objects, strings and numbers, and I'm using notify to print that out, to be able to display that in the debugger. Down here at the bottom, we can use most of the C# language. So for example, I can create a class here called user that has first name and last name, and I can create a user E1 setting the first name equal to Abel and the last name equal to Baker. And I can use notify again to print that out. I can create another user called entity2. First name is Charlie, last name is Delta. I can create an array of entities, and I can display the array of entities. This is still a simple version of the main method. It doesn't return any values, but I could also return any of those values, back to my enterprise application if I wanted to do that. So in answer to the fellow who asked, what else can we do? This is just showing a little bit. We're going still a little bit slowly, but let's run that and see what happens. So the first thing we need to do is to recompile it. So again, click rebuild, make sure that we get the messages here, and then we go over to the, go back to the debugger, and I can open that new file. Into the bin, into the debug, and there's the new AVM file. There's the source code for that, and I can simply F10 again to advance through that. And if we look on the far left, the bottom left-hand corner there, we'll be able to see the output from these log messages as we go. So there you see log 1, log 2, notify, we're going to set this to 10. We're going to print out the number 10, so you can see the string 10 and then the number 10. And then we have the array of values that we're going to print out. Print out an object, print out an array of objects, and then we'll just go through to the end. So very easy, very comfortable. Like if you've done any programming, even Java programming, you can see that creating these smart contracts with C# is very easy. Very easy to debug, to do the normal things that you would do in terms of tracing. I can also, I can hover over any of these variables and it will tell me the values of those variables. So if I go up here to 10, it'll tell me that the value is 10. So Sergio's done an excellent job in bringing this all together. Let's keep going because it sounds like people would like to see some more elaborate demonstrations. So let's go into the third lab. So this is the storage lab. And it's fairly simple. The basic NEO storage model stores what are called key value pairs. If you're familiar like with Salesforce, it's all based on a big database that just has keys, whatever character string or binary value you want to use for a key, and you associate it with a value. So it's like a huge two-column table. So we can see up here at the top, we get the storage context. I call it CTX just to give it a name. We're going to set a string called item key. So test storage key, that's going to be the key, or the key that we're going to use to store a value in the NEO storage. What we're actually going to do is we're going to try and doing a storage.get. So this is assuming that you haven't you're running this for the first time, and what we're going to do is we're going to say get. We're going to pass in the CTX, the storage context, and the item key, test storage key, and see what we get back. If you go to get something from NEO storage and it isn't there, you will always get the value 0 back. So what we're doing is we're testing to see if the item equals 0. If the item value equals 0, then we're saying the storage key isn't set. What we're going to do is initialize it to 1. If it has been set, i.e. we've set it to 1 earlier, we're going to print out the message that it's already been set, and we're going to add 1 to that value. And just off the bottom of the screen, we're going to call storage.put, passing in the context, the item key, and the new value. So the first time I run this, it's going to come back 0. I'm going to add 1 to it, and I'm going to put the value 1 into NEO storage. Every time I run it, after that, it's going to find the old value of the item, add 1 to it, and then save it back. So we've created a simple program, but it's a little counter program, and we're running this in the debugger, so it isn't actually writing it onto the NEO blockchain, but if we had taken this smart contract and put it onto the NEO blockchain, we would actually be writing values. We'd actually be writing the state of our smart contract onto the NEO blockchain. So the developers, the core development team that Malcolm leads back in Shanghai has done a very good job of making the NEO blockchain simple to use, simple to understand, simple to use, simple to program against. Again, you get the context at the beginning, and you simply use storage.get, passing in the context and the key, and you use storage.put, passing in the context, the key, and the value whenever you need to update something. So we can, like the previous examples, we can go in and rebuild that. And then I can flip over to the debugger. And we're going to go up to here. Open the AVM file. Again, that's the bytecode file. The debugger's loading that into the VM, and we can see it there. And so if I go F10, now I may have run this before, so it might not be starting at 0. We will have to see. So I did run it before, and so if we hover over the hover over the item value, it tells us that it's equal to 2. Sometimes the debugger will display things in hexadecimal, but we can see that it's set equal to 2 because I've run it a couple times before. The other thing I can do is I can press F6. Remember I said F6? And there we can see what the simulated Neo storage looks like. So there's the key. Test storage key is that key that we gave to the put operation, and we can see that it currently has a value of 2. If I had used other keys or maybe had run this several times, you would see the Neo storage all being displayed here. Each smart contract has its own Neo storage. So I'm not going to see anybody else's data here. And if I have, let's say, 5 different contracts, I'm only going to see the data for this contract. I'm not going to see the data for the other contracts. That's why I used that term earlier. I called it smart data. In the middle is the data, the values of the data, and then wrapped around it is the smart contract, the logic that we write in C#. The only way to get at that data is through the smart contract. And this allows us, when we talked earlier before about the requisitions example, this allows us, we're not just creating a database here, right? We're creating smart data where we can use the C# code to write business rules and logic to control what happens with that data. So this is the end of Module 1, just 3 simple examples. We did the hello world. We showed some different types of data that we can use in smart contracts in the second lab. And then here we've shown how we can save that data into storage. When we go into Module 2, 3 more labs, we're going to start looking at more sophisticated logic, more sophisticated smart contracts that wraps, different kinds of data. So I'm just going to flip back into some PowerPoints, and I think we're coming up to the break fairly shortly. So let me just continue a little bit with the PowerPoints before we get to the break. Again, all of this code is in the PowerPoint, so I'm just going to flip through these fairly quickly. So here's an example where this is from the NEP5 Smart Token Lab that we're going to see in a little bit. But you can see I'm using different kinds of keys here, and you can see the value of the transactions that I'm doing with the NEP token. These often when we hear about blockchain, there's the term distributed ledger. So a ledger is like a ledger in accounting purposes. Think of your checkbook as a ledger. So this is a ledger, and so these are entries for different people, for different accounts. If you remember that big circle that I showed you with the green arrows and the money going around in a circle, well, each of those accounts is represented here. And this is the balance, or the amount of money that's in each of those accounts. So the purpose of the NEP5 token, smart contract that we're going to look at, is about managing a distributed ledger using neo-blockchain technology. And so the concepts, like most things, are fairly simple, they're fairly straightforward, but it's how do you put it together? I'm assuming in Turkey you have Lego blocks, children's toy. Neo's like Lego. We give you some blocks, some with 4 knobs on top, some with 8 knobs on top, some with 2 knobs on top, and how you use those to build your smart contracts, and then how you integrate those with your business application is where you bring your expertise. This is the full API for storage. So there, again, it's fairly simple. There's put methods, and there's get methods, and there's delete methods. The only difference is some of them are used to send byte arrays into the storage. Sometimes it's integers, and sometimes it's strings. Sometimes the keys are strings, and sometimes the keys are arrays of bytes. And the same thing for get and delete. So very small, very concise, very easy to understand API. Oh, this is lab 3, so this is the one that we just looked at. This is the whole thing on the, yeah. This is kind of my backup, like if Visual Studio didn't work, so that's my explanation that I'm giving you. So that's the end of module 1. So let's talk a little bit about Neo. Some of this will be a little bit of an overlap with what Malcolm talked about this morning, but when I think of Neo, these are kind of the main parts. So it's a project. It's a non-profit, community-based blockchain project. If you go to the neo.org website, that's what you're going to find. The part of Neo that's dearest to me, closest to my heart, and in Turkish you say, it's a part of my liver. Is there Turkish expressions? When you have a close feeling with something. So the software platform is part of my liver, and more particularly, it's using it for what I call third-generation distributed applications or third-generation enterprise applications. There's 2 cryptocurrencies. We call it a dual cryptocurrency model. There's Neo and there's Gas. I don't think I've included too many slides to explain those. I might be wrong. I've forgotten which ones I kept in and which ones I didn't. But Neo is the currency that gives you voting power on the network. When Malcolm this morning was talking about how Neo is going to grow the number of consensus nodes, what determines whether a consensus node is an ordinary node or a consensus node is by how many votes, how much Neo the different people who are operating the network have. So Neo is like voting power, but when you run the smart contracts, when we ran them in the debugger and it told us how much gas is sometimes called the utility token or the fuel token. So it's like the operating fund. So whatever happens in the network, you don't use your Neo for that, because Neo is like voting power. You want to accumulate and you want to hold and you want to keep the Neo, but the everyday things that you're doing, you use gas. And when you run a smart contract, when I call into the smart contract, you don't have to pay gas every time. Remember, you get 10 gas for free. So it's only if you have a very, very complicated smart contract and it takes more than 10 gas that you actually have to pay for some gas. We've been talking, both of us, about the Neo Smart Economy, and then I've talked a little bit about this global community. How many people have joined the Discord group? I know we had internet. Oh, good, good. Okay, I got one check mark from Malcolm. At the end, I'm going to talk about many more resources, but I've tried to collect all the different kinds of links and good information for C# developers. And I call it the C# Developers Center of Excellence. And that's the link. It's on GitHub. Everything is on GitHub. There's a very strong Chinese-speaking community called NEL, or New Ecolab. There's also the largest community is around the city of Zion. So there's the work that happens in Malcolm's team in terms of core technology, but things like the Neo debugger tool that I showed you, that was actually created by the city of Zion community. And so they work very close together, very symbiotic relationship. So that's kind of my one slide about what Neo is. Oh, I do have something on the, so I won't repeat myself too much, but there's Neo and NeoGas, and then NeoGas, the short term, we just call it Neo. For those of you that are investors and traders, I don't speak to that group very much, but both Neo and Gas trade on the exchanges, so you can buy and sell both of them. And I don't think I've really, here, this is an interesting aspect of the Neo blockchain. So that gas that we talked about, that gets paid into the network, when it gets paid into the network, an interesting thing happens. That gas gets collected up and gets distributed, it gets spread out to all the people in the network who hold Neo. So if you have some Neo tokens, some voting power in the network, when that gas is spent by all the different developers and people using the Neo blockchain, that gets gathered up and it gets divided, and you'll see in your Neon wallet that you not only have Neo, but every day or sometimes every few hours, you're going to see more gas accumulating there. So just by holding Neo, and the more Neo you hold, the more you participate in the network, you actually get a financial reward in terms of new distributions of gas. So this isn't just a bunch of technology. The founders of the Neo blockchain are quite serious about this concept of the smart economy, encouraging people to become part of it, encouraging people to hold Neo, and then people get distributions, they get rewarded for holding Neo. There's a page, ndap.org. This is where all the different projects that are built on top of the Neo blockchain publish the products and the services that they've created that run on top of the Neo blockchain. When I talk to groups, when I talk to organizations like yours, at this stage, a lot of people say, well, you know, I don't hear much about Neo. I don't know what a Neo person looks like. I don't hear about anything. So part of what I'm trying to do is demonstrate what I call evidence, things that are happening, you know, in the marketplace. And so there's many, many people who participate and build and are building their futures on top of the Neo blockchain. Repeating a little bit of what Malcolm said, and this is from a presentation that Da Hongfei, one of the founders of the Neo project, talked about recently at the Neo DevCon. You know, where they're headed by 2020, so 100,000 transactions per second, using just the conventional technology improvements on the efficiency of the algorithms, but the conventional DBFT algorithm, without doing anything fancy. Let me just say, none of the sharding and other things that you hear the other blockchains having to do to achieve better performance. Just on the current roadmap, the current path that Neo's on, by 2020 they're looking at 100,000. So it's about 1,000 transactions per second today. It depends a little bit on the mix. If there's a lot of simple Smart contracts, it's easily 1,000, sometimes better. But if there's a huge, big ICO and it's a very complicated ICO, very complicated business rules, you know, sometimes it doesn't quite get to 100, or not quite to 1,000. So high throughput, the finality, one confirmation, one block. Once your block has been placed on the blockchain, it is confirmed, it is final, you don't have to wait. Interoperability using the NeoX protocol. There's a kind of a sister organization called Ontology, close relationship with the founders of Neo, who are working on the digital ID piece. And then one of the partners isn't exactly the right word to use, but one of the other communities that is building on top of Neo has created a stable coin, and that's called the Alchemist project. Some of the use cases, these are fairly conventional use cases. The ones that are the most talked about, of course, are supply chain. That's been mentioned today. You hear about companies like Starbucks now is going to create a blockchain so that they can prove to their customers where the coffee comes from, or if they're using organic coffee, that it's certified organic, and here's the supply chain that went through. Wineries are creating blockchains to show the origin of the grapes and the variety of the grapes that were used to create ultimately every bottle of wine. Business process re-engineering. So I showed that simple example with requisitions. I actually hope to be able to show that today. I'm about 80% the way through that. But as a general solution to be able to process any type of requisition, I think is a very interesting way. Again, this idea in the neo-smart economy of being able to blend or combine the physical world with the digital world. How many people are familiar with this curve, the technology adoption curve? Yeah. So just, you know, to be kind of just super upfront, we're at the early stage here. You see a lot of capability. There's people that are real businesses, they're using the blockchain, but we're still at the early stage. It's innovators, early adopters, like any technology, whether it's the Neo blockchain or Ethereum or what have you. There'll be a big part of particularly government and some kinds of businesses that are going to wait. They're looking for people like yourselves, the innovators and the early adopters, to demonstrate the technology, show that it works. These people look to these people, and then these people look to these people, and then there's this group at the side here, the laggards. They never do anything. So you need to be always aware of who you're talking to, because if they're one of these people, then don't waste your time. Find people, if you're building on the blockchain today, find people who tend to be early movers or fast movers. It's been very impressive listening. Like, I arrived on Saturday, so I was meeting with different people involved with the workshop, and it's very impressive to see how forward-looking Turkey as a country is with blockchain, and then the people that are involved in all the different institutions that are represented here over these 2 days. So you have a huge head start in terms of that technology adoption curve. So we've made it to the break. Here's a little bit of a cartoon. I'll let you read that for yourselves. It is quarter after, was it 7:15? So at 5:30, it's 7:30. Let's come back and we'll start again at 7:30 in 15 minutes from now. Thank you very much.
Michael. How much time we have left? Can you finish in 30 minutes, 40 minutes? Another 1 hour?
The lady from translation was asking, and I said I would stop at 8:30.
30 minutes, okay. No, not too long. We have to go for lunch as well.
Yeah.
Okay. 30 minutes is okay.
Hard stop at 8:30.
Okay, very good. Birazdan bu QR kodu öldüreceğiz, kapatacağız. Kayıt olamayan varsa lütfen olsun. Kaçak öğrenciler de oldu tabii ama yapacak bir şey yok. Yarın sabahleyin Peter Gazi konuşacak. Çok önemli birisi. Biraz araştırma yaparsanız mutlaka bekliyoruz. IOHK'den geliyor. Cardano'nun da altyapısı. Çok daha acayip bir şey. Öğleden sonra bildirilerden bir tanesi biliyorum. Seyfullah. Seyfullah burada mısın? Gitti mi Seyfullah? Çıktı. Seyfullah da bizim community'nin içinde olan hackerlardan blockchain ile ilgili bazı açıklar buldu filan, onları yayınladı. O makalelerini anlatacak genç bir arkadaşımız. Hatta TÜBİTAK'tan da bir destek aldı galiba. Evet. Başka bildiriler var. Çok seçme bildiriler. Şimdi hızlı bir şekilde yarım saat 45 dakika içinde bitirmeyi planlıyoruz. Herkes çok yoruldu. Katılım belgeleri aşağıda. Bugün alabilirsiniz. Yarın da alabilirsiniz. Ayrıca diğer sertifikalar da bu gece basılacak. İnşallah yarın teslim edeceğiz aşağıdan yine. Yarın öğlen civarında teslim edilmiş olur. Hepinize teşekkür ederiz. Şimdiden iyi akşamlar. You will finalize the session.
Thank you. So, yeah, I took a little bit longer, and it looks like we lost a few people, but these must be the best people that are still here. So I'm going to go a little more quickly through the content. There's the 3 labs. I'll probably just go through the source code on the PowerPoints. You get an idea of how to develop in Visual Studio already and use the debugger. So it's just the same. This is actually, I think, one of the more important topics, which is the NEO architecture. What I call the NEO reference architecture, and there's a project called NEO-Charm. This highlights the key technology components, and we're going to go through each side of the diagram. Here we're talking about the developer tools on the right and how they connect together. This is what's happening when we were using Visual Studio and using the debugger. And then I'm going to talk a little bit about the NEO virtual machine and how that works together. Okay, so here's the developer tools. So you start by coding your C# file in step A. You compile that with Visual Studio, the compiler, the C# compiler in step B. And it actually creates an ordinary Windows assembly, an ordinary Windows DLL. What's very interesting here is how NEO has taken the Microsoft compiler technology, and rather than writing their own compiler that takes the C#, they're using the Microsoft compiler. They're using the Microsoft compiler, taking the output of the Microsoft compiler, and then in step D, that's when they take the DLL and they take the bytecode, the Microsoft intermediate language in step C, and they turn that into the NEO bytecode here in step E. So for example, if you turn on the optimizing compiler in Visual Studio, if you use release mode, the performance improvements you get from the Microsoft compiler actually help you and make your NEO VM smart contract run faster. So it looks complicated. I tend to be kind of an architect and I like to put everything on one slide. But once you get that NEO VM, AVM file, then that gets loaded into the debugger, and I said that the debugger was running a copy of the NEO VM. So this is running off-chain, and that's what we saw demonstrated in those 3 labs earlier. So the short story, the easiest story is we go from Visual Studio into the debugger, and although I was running those separately, If you're familiar with how to set what's called the debugger properties in Visual Studio, you can launch the debugger directly and get a very quick, rapid edit, compile, debug story going so that you can iterate very, very quickly. And amazingly powerful the way that works. So here, just illustrating what I talked about, C# compiled into Microsoft Intermediate Language. Neon is the name of the .NET compiler. That takes it into the AVM code, and that runs in the VM. So very smart in their ability to reuse and leverage the Microsoft technologies there. When we talk about the NeoVM bytecodes, there's kind of two categories. There's the regular instruction opcodes, flow. Think of this like, the assembly language. There's the flow control, stack operations, string, logical, arithmetic, the regular instructions, and they by default take 0.001 gas. There's a few opcodes that are special. They're a little more expensive, and you can see how much gas that they use. There is on the next slide, we're going to see the NeoVM, and it can call down into through an interop layer to some services. So the NeoVM is just a virtual machine. It doesn't know anything about blockchains. It doesn't know anything about transactions. The way the NeoVM understands about blockchains is by talking through the interop layer to these services. I'll show you in the diagram. But here I'm highlighting that those calls that leave the virtual machine and talk to the interop services, we call those system calls. And because they have to cross that boundary, they're a little bit more expensive, and we see some examples there. So here's perhaps the picture that I should have shown before. So there's the virtual machine. That's where your AVM code, that's where your bytecode runs. You can see the script, K is your actual bytecode. There's instruction pointers, all of the things that you'd expect to be part of a virtual machine. I was talking to a couple of people during the break. That's actually implemented in C#. If you want to have a virtual machine running in a completely different program, like a non-blockchain program, you can run the NeoVM there. You can use that as an example. And then down here, we have the interop layer. So here is the different services we see. So remember we were using runtime.log and runtime.notify in the hello world example. That's the runtime service. Somewhere in here is the blockchain service. I'm too close. The blockchain service, here's services for working with transactions, and you access that through the interop layer. So I have a fancy name for the boundary. I call it the red line. So anytime you call across the red line, it's going to be a little bit more expensive. So here's some examples. So let's say we want to read a block off the blockchain from inside our smart contract. So we're going to use the blockchain system calls. And you can see that they're 0.1, 0.2 gas. So for example, if you wanted to find the most recent block and get the timestamp out of that most recent block to use it as a timestamp in your smart contract, it might cost 0.3 gas to do that. And it's because your script is calling down through the interop layer. In Lab 3, when we were getting and putting data into Neo storage, similarly we're calling across the red line, and in that case we're using the storage system calls so that we can see that getting data from Neo storage, reading data from the blockchain is relatively cheap. It can be quite expensive to write data, but generally in blockchain applications you'll have some transactions that will read something, change it, and write it back, like we did in the storage. But most often you're reading the data back. You're reading existing data back from the blockchain. The first 10 gas is free, so if you're doing a lot of writing in one call, in one invocation of your smart contract, you can probably change up to 6, 7, 8 kilobytes worth of data, which is actually quite a bit of data for a blockchain application. So here's the labs. I'm going to step through these, not too quickly, because it's instructive to learn them. So here in Lab 4, I'm going to start showing one of the most common patterns that you will use to create your blockchain application. And then in the next 2 labs, we'll use that pattern, we'll put it to use. So probably a little bit small. Yeah, I'm going to blow it up a little bit here. So looking here on the left, oops. We started with a main that had no arguments and it just returned void. The more common pattern is for it to take a parameter called operation, a string parameter called operation, plus an array of objects, and it will return an object. This allows your smart contract to return any kind of data. It could return a Boolean value, it could return a number, it could return a class. And so we see that at the very top of our pattern here. And then there's the operation to be performed. So this is when you call into your smart contract, you want it to do something. So some of the operations that we have here in the example are you want to do a query, you want to read some data back, you want to delete some data, you want to do a register operation, or you maybe want to do a transfer operation. When we talked about the NEP5 token or altcoin, one of the things we want to do is transfer tokens from one person to another. So you could have, when you implement an NEP5 token, you have a transfer method, and then you'd have a transfer method and you'd be passing as part of the arguments what address is it from, what address are you sending it to, and what's the amount that you want to transfer. We'll look at a specific example. So there's the arguments. That's the logic or the pattern that you use on the inside, the middle of your smart contract, and then at the end you return an object. So in this particular case, I'm returning either true or false. True if it's an operation that the smart contract understands, and false if it's an operation the contract doesn't understand. So that's the very basic, simple pattern. Again, in general, your main method can have whatever arguments you want, and it can return whatever arguments you want. But in terms of what is common, and when it comes to implementing, for example, a token that needs to work with a wallet, wallets expect these kinds of patterns, and that's the way that smart contracts work with some existing software. Let's look at that pattern, and in the beginning I talked about implementing like a domain name service, kind of like DNS on the internet. So let's have a look at what that would look like. I'm going to skip over this. So we want to be able to implement commands like query, register, delete, and transfer. So query, we want to send a domain and we want to get back who is the owner of this domain. Register, so we want to register that domain to an account. So this is what a typical Neo account looks like. We might want to delete a domain from the registry, but we only want to delete it if the command came from the account that was the owner. Or we might want to transfer an existing domain to a new domain. So we can step through that example. So we start with the main line. We have the operation, which will be query, register, delete, and transfer. And then we'll pass in the different arguments depending on which operation it is. So we're going to take the domain name from the first argument. If it's query, we're just going to call our method query domain, passing in the domain name. So just very simple C# programming. If it's delete, we're going to call the delete domain, etc. So this is what I call the dispatching loop, or the operation processing loop. And the same for register, and the same for transfer. In the case of transfer, we need 2 arguments. So we've already got the domain from args0, and so here we're getting the to address using args1. We have, data type coercion, the standard mechanisms for programming in C#. So here's an example what query domain looks like. So where's this registry going to live? It's going to live in Neo storage. So we're going to be using get operations to do the query. So to do the query, we just get the context. We do a storage.get asking for the domain name. The domain name is the key. And if it comes back with a length of 0, that means it's not in Neo storage. It's not in our registry. So we're going to do a runtime notify. We're going to put a message in the log, and we're going to set the result equal to 0, and like a null value, and we're going to return that. If it is not equal to 0, that means that it is in the registry, and so the value for that key will be the owner account, and so we'll return the owner account. Very simple patterns for creating smart contracts. Register is a little bit different. The thing I want to highlight is there's a new runtime method here. It's called check witness. And what check witness means is when register domain is called, it's being passed the domain name, like test.com. And the second argument is the owner. This is the the second element of the args array. And so what we're doing here is taking that string, the account string, and check witness is checking to see if that account represented by owner is the same as the account that is calling into the smart contract. So if this is my smart contract and I'm calling into it, what check witness is doing is saying the person that's calling in, do they match the value of that owner field? So I've said take test.com and register it to, let's say, Michael Herman's account. But if it's not Michael Herman calling in, if I'm not using that account to call the smart contract, that method will fail. So if it fails, it said the owner argument is not the same as the sender. So the owner for the smart contract, the owner for the domain is not the same as the sender, the person that's calling in. So that is a very common pattern there, and that's how we can do some authentication and authorization. If the sender, the person calling the smart contract, is the same as the owner, then we go ahead and we first do a get to see if it's already registered, because we don't want to register it again. So if it's not equal to 0, that means that it is already registered. We'll print out a message that it's registered. Otherwise, we'll finally using the domain name as the key, we'll put the owner into the registry, and we're going to return true. Very, again, common pattern that we saw originally in Lab 4. We're seeing used in real life here in Lab 5. And then here's the other ones, transfer domain, the same sort of thing. You shouldn't be able to transfer domain if it belongs to somebody else. So we're using check witness again to check who the owner is. Delete domain, same story. I don't want anybody to delete a domain that's registered to me. So I'm going to first do a check on who the owner is in the database. If it's not in the database, if it's not in Neo storage, I'm going to print a message. If it is in the database, I'm going to make sure that that the owner of the registry, the owner of the entry in the Neo storage is the same as the person calling in. Let's go to the last lab here, and this is the NEP5. So NEP stands for Neo Enhancement Proposal. So in Ethereum, if you're familiar with ERCs, this is the Neo equivalent, and NEP5 specifically deals with tokens. There's a little bit more code here, but it's basically the same pattern. There's standard methods, standard operations that an NEP5 token needs to implement. Total supply, how many tokens are there? Is it 10,000? Is it 1 million? What is the name of the token? What is the symbol, like the 3 or 4 letter symbol for the token? How many decimals are in the amount? And then we get into more interesting methods like if I pass you an account, what's the balance? How many tokens are in that account? Oh, just a minute. So balance of is a standard method. Transfer is a standard method. Transfer we can see as an example. So if it's transfer, we need 3 arguments. The first argument is where are we transferring it from, what account are we transferring it to, and what is the amount. So those are the 3 arguments that come into our main. And then I'm going to call the transfer method passing from to an amount. This variable here, I kind of skipped over it. But this is the one that has all of the information about what is the name of the token, what is the symbol, how many, what is the total supply. So that's kind of like global information that we pass in. So if we go down and look at transfer here, again, we're using check witness to see if the account that we want to transfer the tokens from, we want to make sure that it's the same person that is sending in the transaction. We don't want people transferring tokens from somebody else's account. Are the from and to accounts the same? If they're the same, there's no point in trying to transfer money between 2 accounts that are the same. So we just return true. If they are different, then we're going to get the from balance for the from account. We're going to check if the from balance is greater than the amount. So if the smart contract is being asked to transfer 100 tokens, we want to make sure that there's at least 100 tokens in the from account that we're starting with. If it is, what we're going to do is we're going to update the from balance, the from account, to be from balance minus the amount we want to transfer. And then we want to update the ledger for the 2 accounts. So we're going to get the to balance, and we're going to add the amount to the to balance and write that into the to account. So when people talk about creating altcoins or new cryptocurrencies, it's as simple as a few methods like that. But because it's simple, people think that it's easy to do it correctly and perfectly. Often when things are simple, that's the easiest way for problems or for bugs to show up. So you need to be very careful creating cryptocurrencies, even though the technology makes it very easy to do. So we went through that rather quickly. I want to make sure that I try to get done here. Oh, I still have 30 minutes. I think we're doing pretty good. So this slide Malcolm used this morning, I want to highlight it. So an important principle of the Neo blockchain is that transactions should be free. If you think of yourselves as creating a business application, maybe that the general public will use, if you're in the Turkish government, you want an application that the citizens will use, or you're a company or business and you want to put some blockchain technology as part of your website, you don't necessarily want the citizens or your customers to have to pay gas to execute their transactions. So the first 10 gas, again, is free, and you can do an awful lot within that first 10 gas. If you find that you need to do something more complicated, maybe you have to do it in 2 separate calls, 2 separate transactions. And if that's possible, then it's like you have 20 gas to work with. The main chain speeds, again, we're hovering around that 1,000 transactions per second currently. That's going to scale and scale very significantly as we move forward. I remember, I don't own very much cryptocurrency, like less than $1,000. And I remember the first time that I bought some, I forget if it was Bitcoin or I bought some Ethereum, this whole idea of having to wait for as long as an hour to find out if my transaction went through, I found that very odd. And that's because of the number of confirmations that are needed either on the Bitcoin network or the Ethereum network. Again, with NEO, once your transaction is put into a block, it's immediately confirmed. And we don't have a bunch of miners competing to put transactions on blocks. Malcolm explained that this morning. What happens using the DBFT algorithm is the consensus nodes decide amongst themselves which consensus node is going to process the next transaction in the next block. So that's why he showed you it was a linear, it was a sequential creation of transactions being placed into blocks, because DBFT decides in advance who's going to do the processing, who's going to process the transactions, and who's going to place them into the blocks. So that's why one confirmation and only one confirmation is required. So when you take these factors all together, particularly the no transaction fees, it allows you either as a government organization, government agency, or as a bank or a different kind of business to create the business model that makes sense for you, the blockchain business model that makes sense for you and makes sense for your customers. So I guess it's a few years ago, but in North America, there's the Burger King hamburger chain, and they had an advertising campaign, "Have it your way." And so the same thing, and I think you've heard the story a little bit this morning and again this afternoon, the ability to use whatever programming language you want, the ability to use whatever tool set works best, being able to program in C#, Python, Java, Golang, JavaScript makes it very easy. So you can literally have your smart contract any way that you want. In terms of the developer tools, I really just focused today on the NEO debugger and the compiler and using Visual Studio. There's many other components. One of the questions during the break was, okay, I understand you can do off-chain testing and development, but when I want to transition and start running on the real blockchain or a version of the real blockchain, what do I do? So there's a version of PrivateNet. It's called PrivateNet. It's the complete NEO blockchain, but it runs just on your computer. It's packaged as a Docker container, so if you have Docker installed, you can install that container into Docker, and it runs just as if it was a real node, a real consensus node, but it's local to your computer. There's also testnet, so running on the internet, a public version of the NEO blockchain, and there's a faucet where you can get gas so that you can deploy your smart contracts and test them on testnet. And then finally there's the main network. And then you need gas to be able to deploy your smart contract on the main network. So in the PrivateNet, the Docker image, it comes pre-configured with thousands and thousands of gas. So you never have to worry as a software developer about not having enough gas. So there's the main components. And then here's the projects on GitHub where you can find those. In terms of how to configure the Docker container, you can look at it from two perspectives, as a C# developer or as a Python developer. The Python developers, you actually created that Docker container, the Python community. And so if you're, I know there were some Python people were asking me about that, go onto Discord, go into the Python channel, and say, I'm brand new to Python, smart contract development, where do I need to start? And several people will help you. The same thing you can do for any of the languages in Discord. There, at the top there, there's what I call the Neo Blockchain Quick Start Guide for .NET developers. It's a 10-step process about how to set up all of the tools and how to set up that Docker container to use for C# development. And it's in a project, so MW Herman 2000 is my, my account, my identity on GitHub. So if you look for .NET Quick Start, you can find that, you can find the link to that and find those 10 steps. Screenshots of every step, kind of going back to my Microsoft days where we had those hands-on labs. Painful to create, getting screenshots of every step, but it'll take you through setting up everything that you need to know. And I'll show you that a little bit here in a moment. I don't really have time to show Java or Python. We didn't get through all the C# stuff, but you know, that's what a Java smart contract looks like. So very similar, identically to what we see in C#, just the difference in the language syntax. The first simple labs that I used, the idea for those labs I actually got from the Python smart contract workshop. And so there's a link there. And on the GitHub page that I showed you before, that link is there as well. So if you're a Python person and you'd like to do the same labs that I did today, but do them using Python, go to that link. That link also has all the steps to set up a Python environment. Again, how to get Docker installed, how to get the Docker container installed. So it's what I've done for C# with this workshop. There's also a Python version of that. What does a Python smart contract look like? There you go. So now that you know a little bit about C#, you know a little bit about Neo smart contract development, you can see this is actually lab number 3, where we're setting the item key, being able to test storage key. We're doing a get. Context is the storage context. Notify. So they have some short forms, some shortcuts in terms of the names of some of the methods, but you can see that that's line for line what we did in the third lab. And that's the same regardless of what language. There isn't a different API. It's just different depending on the requirements of the language. Oh. So I used to be an Ethereum developer, and now I'm a Neo developer, so I thought I'd better tell you why. So how many Ethereum developers are left? Okay. So when you create a smart contract, an Ethereum smart contract using Solidity, what you're creating is a class. And as a class, there's a little bit of data structuring there, but as a class, you're really representing one entity, a simple entity. And when you deploy that class, that Ethereum contract onto the Ethereum blockchain, it's creating an instance of that class. So when I think about Ethereum, I think about it's good for creating simple things. And what's the most simple thing that Ethereum is famous for? It's famous for creating altcoins, because altcoins are really simple objects, like I showed you in the Neo example. So Ethereum is good for, you know, what I call blockchain version 2 altcoins, simple single entities with a few methods. And I know it's possible to use more than one Ethereum smart contract and connect them all together, but still a single smart contract is a single simple entity. So I think of, when I think of Ethereum as an enterprise application development platform, I find it's very limited. Very limited in terms of the limitations in terms of structuring data. On the other hand, a Neo smart contract, like I've showed you, is actually a program. So it's not only has those operations, which is similar sometimes to Ethereum, but the fact that you can have many different objects. In the second lab, we talked about the user class that had first name and last name. You can create and use dozens and dozens of different entities in your Neo C#. I showed a very simple way of using classes, but in fact you can get very, very sophisticated in your approach to that. So when it comes to creating real business applications, at the break somebody was asking about healthcare applications. When you're the types of things that you're trying to model in a electronic health record would be challenging and perhaps difficult to do in Ethereum and more straightforward to do in Neo. We're doing another few minutes, but I'm going to wrap up as quick as I can. This I will skip over a little bit. Part of what I've implemented on top of the C# class structure in Neo is the ability to actually create real entities that know how to save themselves automatically into the blockchain, how to automatically save themselves into the key value store. And just as an example, following that theme of building more sophisticated applications, this is actually a simple application that you can draw lines from point to point to point, and the points are saved on the Neo blockchain. And that may sound simple, but when you start the application, it asks you to log in. So you need a username and you need a password. So we needed I needed a user credentials object, and I stored that on the blockchain. And if you gave me a user ID and a password that wasn't on the blockchain, I asked you if you wanted to create a new user credential. And so that's a self-contained class now that gives me the ability to create a user directory and have people log in and out of the application. The XY points, I created a class called userPoint, and it's just an array of XY coordinates that represent the line. So everybody that has an account also has an array of user points. And then finally, there's an object I called Neo Counter, and it's just a counter to keep track of how many points you have. So fairly simple application. It's certainly not a business application, but you start to think about the ability to model your data and build much more sophisticated data structures. To me, that's a lot of the advantages that the Neo platform brings. I'll just skip through that. So at the end here, again, I'm trying to encourage you to think beyond just alt tokens and cryptocurrency. You know, how would you take a business process and how would you enact that business process? How would you implement that business process as a smart contract? When I started to work on this diagram, I did the obvious thing. I put the requester, I put the approver, and I put the person in accounting on the left-hand side, because to me, it started with the people. Because I was thinking of intermediaries. I was thinking of the people who had to be involved. Where are the people now? The people are out at the edge of the process. And in fact, we said that if the requisition was below a certain amount, we don't even need any people to be involved. Or maybe it's an intermediate amount and we need to have the payroll or the accounting clerk involved. Or maybe it's a larger amount and we need to have the manager involved. So the idea of taking the intermediaries out of the middle of the process and moving them to the edges, moving them to where they can provide value is sort of my call to action. This is an example of some of the modeling I'm doing to create that application. I'm not going to go into that in a lot of depth, but there's the entities that run inside my smart contract, and then there's the entities that run down in the blockchain. Where the Neo Draw, the drawing program, had a small number of entities, I start to get into more sophisticated entities, like the contributor, the different kinds of people, and the requisitions and the different kinds of objects and the relationships between those objects all modeled on the blockchain. So we are actually in the wrapping up stages here. So earlier I talked about the evidence. What's happening? Is this NEO thing for real? What's going on? So there's lots of meetup groups now. Farouk has the NEO blockchain Turkey, or sorry, I can't pronounce, I'm losing my voice. There's been hackathons that have focused entirely on NEO development. There's a whole Asia tour that just finished. NEO Blockchain Vancouver, your conference here, good to see. This is interesting. So there's lots of competitions being held for distributed application development. So City of Zion, that large open source community that supports a lot of the tools, they had a competition. The competition at the top was co-sponsored, NEO and Microsoft. The prize money, $500,000 US. For the winner, the first place, $150,000 US. So we're talking about very serious interest, very serious money, backing these competitions. We've seen this slide already, all the different projects that are running on NEO. We'll skip over that. Switchers, projects who have left Ethereum and moved over to NEO. Not going to go into the details, but there's many, many projects who are now running on the NEO blockchain instead of Ethereum. So finally, different resources. So there's a number of videos and webcasts. You'll find these all in the PDF. There's also a Reddit group, up to 88,000 members. It's one of the largest Reddit groups, I think, at least for blockchain out there. There was the NEO DevCon in San Francisco, the end of January. So all the sessions, all the YouTube are on YouTube for you to watch, including Da Hongfei. He's the founder, one of the founders of the NEO project. So his keynote presentation is there and worth watching. All the other links where you can go and learn more about NEO. The NEO C# Developer Center of Excellence that I talked about. If you need to send me an email, neotoronto@outlook.com. This is the quick start guide for .NET developers. I talked about all the different steps, all the screenshots to help you. The reference architecture we've seen, we'll skip over that. And so the next step, the call to action, you've gone through some of these already. You've joined Discard, you've got some of the tools in place. Just a reminder of those 4 questions to ask when you should be using blockchain technology, and how to use it either for new applications that need blockchain technology or to extend an existing one. I'm going to skip through a little bit of this stuff so we can wrap up. My background is, I've talked about my Microsoft background. I started with the very first version of Microsoft Windows back in 1986. And so we've seen all these different versions of Windows, 23 or 26 different versions of Windows since the very first one. I think blockchain, I think the NEO blockchain in particular, is going to be an important platform just like Windows, and I'm very serious about this. A platform that's going to enable a whole generation of applications. We're going to see a whole new generation of software partners and government partners and commercial partners building on the NEO blockchain and creating this new generation of applications. And there I illustrate that. This is 0 to 1 concept is from a book called 0 to 1 by Peter Thiel. I encourage you to read it and understand this concept. That only once in a while do we get what is called a 0 to 1 offering, a 0 to 1 platform, something that's brand new and different. And then after that, everything else, after that, see, I have to stop. I wore the microphone out. After that, everything's what's called a 2 to N offering. It's something that's based on whatever the original thing was. So Google has solved the internet search problem. It's the 0 to 1. Anything that happens with internet search is always going to be a 2 to N, and it's going to be worth less than the 0 to 1. You know, we have 3 main operating systems, right? Android, Windows, and iOS. If you wanted to make a big business, it's probably not creating another operating system, and that's the theme here. But blockchain is a new game changer. So that's the end. Here's how to reach me again, neotoronto@outlook.com, and my other links. Thank you for staying to the end. I still have 10 minutes, but I'm not going to use it. Thank you.